Esta conferencia comenzará a grabarse.
To analyze the topic we have today with us. Bernd, sorry because my German is non-existent, so the surname will be a disaster. Bernd Wozniak. Okay, so welcome, Bernd.
It's good.
It's bad, I'm sure, but anyway, welcome. We will start immediately. You have 20 minutes for you, okay? And after that 20 minutes, we will open the dialogue with all the attendants, okay? But so I'm giving you the presentation right just now. Do you have it?
Yes.
Perfect. We are seeing now your presentation. Good. Very well.
Okay. Do you see the
Good morning,
GoToMeeting?
Antonio. Just a very brief hello. And you look different today, huh? Less.
Less formal. I prefer this look. Sorry. Thank you, La. Later we can speak about yesterday. Thank you. But I need to say thank you to you and your team because it was very important what we did, and it was thanks to your collaboration, thanks to your contributions. So later, if you want, we can dedicate some minutes to that. Thank you. Per.
Good. Then, thanks a lot for the invitation. I'm very happy to present to you what Infineon is doing on Edge AI and what is done here in the Silicon Saxony cluster around Dresden. My name is Bernd Waschneck. I'm with Infineon since 2014. I lead the system innovation team here in Dresden, and we are working on Edge AI, and that's why I was asked to contribute here. I want to start with a very general consideration, and that's the questions how we want to interact with machines. How do we really want to have this interface? And if we think about how we interact today with a smartphone or with a computer, it's very much in the sense that technology gives us a frame. It's not very human-like. So if we speak to each other, now you see my video, you see my gestures, you see my face that is kind of has certain mimics. And all of this is in a virtual conversation most of the time lost. So if you think about how you type on a smartphone, it's a really tiny screen. You type on a virtual keyboard, and that's an interaction that is completely unnatural. So we have to move in a direction where the smartphone has the same sensors as we do, or our electronic devices have the same sensors basically that we humans have, and the same processing capabilities behind it. And with these processing capabilities, we are coming to the AI topic, because AI is normally the science of taking human capabilities and transferring them to a machine. And at Infineon, we want to do this at the very edge. That means on the devices that the users are using and directly at the sensor. So bring the intelligence directly to the sensor in order to make the sensor so smart that we have a completely natural and human-like interaction. Of course, this starts with Infineon's sensor portfolio. So in order for this interaction, you need certain sensors, and we have them already in the market. It's of course a microphone. So you all know the voice assistants today, a pressure sensor with which you can do a lot, environmental sensing, and very interesting for these natural interactions are the 3D cameras, the radar, and the time of flight. And on the one hand, we want to combine this to have then smart ears, a smart feeling, a smart nose, but also smart eyes or even a sixth sense, because with radar you can get more information than actually we humans can perceive. And combining this will form new kinds of human-machine interfaces where we want to use the edge intelligence in order to make the interactions more intuitive. So I don't know the audience here. That's why I took this slide in there. Machine learning systems can learn from data and recognize patterns. This might be very easy for you or for some of you, but I still say a few words about it. For me, machine learning is just another way of programming. You also have to have a certain set of rules, but it's a differentiable way of programming. So it's fitting itself to certain problems, to data. Now, if I think about which problems do I want to solve with classical programming and which problems do I want to solve with machine learning, there's a very simple distinction that you see at the bottom here. If you do classical programming, you have your data, your input data, which you should always have, and you have a rule, like a Fourier transform. You can note that down mathematically, and then you can put the maths into some code, and that runs on the data, and you get answers. For machine learning, this is a problem class where it's often very hard to pin down the rule, because that's how we humans actually work. If you see a cat, you know right away, oh, this is a cat, obviously. But then if I ask you, why is it a cat? How do you recognize it? Then you will start making a long list from it has two eyes, it has pointy ears, it has a tail, it has some fur, but the fur can be different colors, and the eyes can also be different colors. And then at least for dogs, there are very different shapes of ears. So suddenly you're in a very large and very confusing rule set, which is very hard for a programmer to write into code. But still, and this is the important point for this problem class, it's very easy for you to say, that's a dog. You know it right away when you see it. And this is now the interesting part where we again combine this with the sensors. The sensors should have the same capabilities as we humans and have a natural interaction like we humans. So the most natural thing is to just learn how we humans do it. So we don't give a certain rule. We want to have the sensor act exactly like this, but we use machine learning and say, for this input, we want to have this answer, and the machine learning algorithm generates the rule. So machine learning is not the answer to everything and solves all problems that we have, but there's a very important problem class that can be solved with machine learning that is very hard with classical program. And this is all of these more natural, intuitive interactions, image recognition, voice recognition, and these things. So now we are a semiconductor company, so I have to give you some semiconductor background here. Machine learning is extremely compute intensive, and you need a lot of data. And that only became possible because of Moore's law. Here we have the scaling of the price of memory, of the price of compute power, and the price of communication. And this gives you the possibility to save large amounts of data, to have enough compute power in the middle, and the communication gives you the possibility to collect all of these sensor signals at one certain point. And you see this is an exponential decrease. That's what Moore's law is. Most people refer, if they talk about Moore's law, about the number of transistors per area, but it's more about the price per transistor that is also scaling with the same amount. It gets half the size, and the price should also be half per generation. And yeah, this just enabled this crazy scaling because most of the algorithms were already around in the 90s. People knew what a neural network was and how to train it, but there was just not the compute power, and that enabled the breakthrough of artificial intelligence in the last around 2014-15. Now there's a problem. Moore's law can't keep up with the requirements anymore. Moore's law is slowing down. So on the left side here, you have the performance of the fastest processor that we have in the market versus one processor from the 70s, and you can see that this is a logarithmic scale, of course. So you have a logarithmic scale here, so the linear scaling is actually an exponential one. And you can see that this is slowing down, and this is slowing down more, and we expect it to be in the future to be pretty much a complete slowdown. At one hand, so you know, some of the things are obvious. If you think about CPU speed 20 years ago, you bought one with 1 gigahertz, with 2, with 4, and that was scaling up, and there's an end to it already a few years. Then the Dennard scaling started, so people started to put more cores in one chip with the Intel Core 2 Duo, or now sometimes with 8 cores, or the new AMD processors. They have over 20 cores in one processor. So that was one option, but it's not enough. So in the end, you're reaching a certain boundary, you're also reaching certain sizes where decreasing the size of a transistor further becomes extremely expensive. And then the price per transistor also starts going up again. So we are at a point where Moore's law has enabled machine learning, but now cannot keep up. And here's one example how the compute requirements for machine learning increase. So from 2013 to 2019, we had an increase of compute power in the largest training that was published online, and you can think that Google is probably even using larger ones. It's a 300,000 times increase in compute, and that means that the compute power needed was doubled every 3.5 months. Moore's law is every 18 months. So this is a completely different scale, and this is for the semiconductor industry in the last years. Of course, this has been great because at first people just start buying more chips. So you just start getting more computers and put more computers in your data center, and then use the scaling like this, so you could still scale. But this is extremely expensive, and it's from an energy point of view really not optimal. So it's nothing that can go on like this. It's not sustainable. Amazon cannot double their data centers now every 3.5 months. This is not an option. And this is why we have a problem. And this is where AI chips come into the game. So what we've currently been talking about is the general purpose processor. Processors that run the code, that run the software, but that have no application-specific functionality. All the application-specific functionality is done via software that gives you a lot of flexibility. You can change the software, could put a different software on it, and then it has a completely different functionality. That's very nice. The disadvantage is that this is not running optimal. So you're always far from the optimal operating point that you could theoretically achieve, because you have to plan for all possible software scenarios that would run on this processor. And this is something you can't plan ahead like this. And actually, machine learning has a very specific usage pattern of processors, which is not well suited for the way we've built processors for 20, 30 years. That's a problem for the semiconductor industry, but also a huge opportunity. So what we are now looking at are AI accelerators or AI chips. These are so-called application-specific instruction processors. There's one popular example that all of you know. This is your GPU, your graphics processing unit. So there was already in the 90s the split between the general purpose processor and the GPU for graphics, because this task was also so special, but yet you needed it all the time, or in computer games, It's something that is really working all the time, that a specific architecture was built just for this task. And this is currently what's happening with machine learning. So semiconductor companies, they always wait for a while until the software market settles. So the first large software wave came around 2015, and the hardware wave is just now starting because all the hardware development is extremely expensive. So all the hardware companies were waiting. Is this really a trend? Will this really stay in the market? Will this really change the market? And today we know the compute requirements will not change. Machine learning will not vanish again. So we need the specific hardware and completely different hardware architectures. The advantage, and I'm sorry, this is in German here, is of course that if you build a specific hardware architecture for a specific task, you can really bring this to the optimal operating point. And compared to a general purpose processor, there's a factor of 100 to 1000 that you can gain by specializing this processor for one specific task. You have an extremely high energy efficiency, which is also a very important point for data centers, but also for edge AI. Yeah, so this is currently what's happening. There are tons of startups in the Silicon Valley, one big in Bristol in the UK and in China, that are working on these AI accelerators, mostly for data centers. And at Infineon, we are working on AI accelerators for our sensors, bringing this extremely close to our sensors. And I want to give you or start with one example. You all know Amazon Alexa. And the keyword Alexa is directly spotted at the microphone, and then the microphone activates the main processor of the device, and the main processor of the device connects to a cloud, so does the cloud connection, and then this is computed in the cloud, and then it is sent back, and then you get an answer. The point is, if you would stream all your data continuously to the cloud, Amazon would be bankrupt because they would need so much compute capabilities, and this would crash every infrastructure that you have in the US, where they have quite a number of users. So the important thing is you have to spot this keyword already at the sensor directly and do this first step at the sensor, and only if it's necessary have the rest of the connection. And an Alexa user uses Amazon Alexa on an average for 3 minutes per day. So 3 minutes per day, you really need this compute power and the cloud connection and everything. But the rest of the time, you only need an intelligence that can spot one keyword. And that is the smartness that we put into the microphone that enables exactly such an application. The other one, for example, is gesture control, where you have a radar sensor in certain applications and then have gesture control. So putting the intelligence close to the sensor has 3 big advantages that are really important. The first one, of course, is latency. You don't need all of this cloud connection. So if you want to have something that is very responsive, or if you have an autonomous car that is driving in front towards a tree, you don't want to have, your internet connection, it sometimes breaks. You don't want this computed in the cloud. This has to be on the car and perfectly directly at the sensor, because there you have the lowest latency. You can react directly. The second one is data privacy. People don't like if their data leaves their device and goes into the cloud. So we want to keep your data on your device directly at the sensor where it is generated. It is also processed. It never has to leave the device, and the person who's using it has the full control over their data directly at or on their device. And with device, then this is always the edge, because the edge of this cloud fog edge network. And the third big advantage is the energy efficiency, which is extremely important. Data transfer costs a lot of energy. You don't want that. And you want to have a very energy efficient processing that is really fitted to the task and the less data transfer you have to do, the better it is. So moving this closer to the sensor has big advantages with the energy efficiency. And this is one of our big selling points, because with this wake up, or often it's this wake up or always on functionalities that you have for gesture control or voice control devices, energy efficiency becomes key, especially if they run on batteries. And the more energy you can save, the better. And that means moving everything closer to the sensor is a solution for a longer battery life. So this is Infineon's vision, how we want to make sensing or human-machine interaction more intuitive. We call it intuitive sensing, and how we use edge AI in order to achieve this vision. Now here's a bit more technical slide, which gives you an overview over the kind of things layer, the IoT layer, and the cloud layer, where machine learning, of course, still needs a lot of data. So at some point you need to collect data, bring this to the cloud layer, train the model in the cloud, and then only the trained model goes back to the things. So training is something that we still cannot do in the cloud. But yeah, the inference, this is something we can do on device, which makes then the IoT smart and brings all of this functionality on your devices directly. So in order to summarize what I've said up to now, AI chips are absolutely necessary to enable edge AI applications, to bring AI out of the cloud to the user devices, to have intuitive sensing where you have a direct reaction and no latencies in there, to ensure that you are the master of your data. For all of this, you need edge AI, and for edge AI, you need AI chips, because a general purpose processor will not be able to achieve this, because Moore's law is running towards an end. You have three big advantages: the low latency, the energy efficiency, and the data security. And the good news for Dresden is, the good news for this area, that we have a really strong cluster here in Silicon Saxony that is working on artificial intelligence with the close connection to hardware. So software, there are a lot of different centers. I wouldn't say that Dresden is the best one here. But in Germany, we are clearly leading, and I think it's also one of the Europe's leading centers where this close connection between AI and hardware is present, and these two are linked together, because this is the next important step for AI. It's not sustainable to just always use more chips. That the scaling of data centers, but also bringing this to the edge, all these cool applications, this will not work without specific AI hardware. So in the end, I want to say a few words about us. We are the Infineon Development Center Dresden, with two focus topics: automotive electronics and artificial intelligence. And for AI, our focus is AI hardware and edge AI. We are currently building up, so if you're interested in what we are doing in a cooperation or in a job, on the right you have my email address, and also a link to our homepage. My department, System Innovation, has a focus on AI-enabled products and IP. I already talked about the smart sensors today, where we put in this system the edge AI and the embedded AI. We think a lot about ultra low power AI acceleration. So how do we reach these really low energy consumptions? And of course, we also leverage the ecosystem here. And one more slide about the center. So currently we are 44 people. The long-term vision is 250, and you notice right away there's still a huge gap. So this is also an opportunity for me to say we're doing cool things. If you want to come here to Dresden and work in a cool team, join us. We've a good partner network, as I said, for this combination of artificial intelligence and semiconductors. Dresden is really unique in Europe. We've also now built up a great infrastructure here at the development center with data acquisition labs where we can generate our own data sets in a small amount of time. We have a huge GPU compute cluster and an agile prototyping lab. And from a project point of view, we have, of course, the electronics part, but also the AI acceleration and some neuromorphic computing to look at the next generation, what will be relevant in 3 to 5 years. Thanks a lot for your attention. I hope I could give you an interesting input and spark now an interesting conversation. I will have to leave in 5 minutes, but for the last 5 minutes, if there's still any questions, I'm happy to answer them.
Thank you very much, Bernd, and congratulations for what you are doing and for the strength of your company. We are willing to help you to grow for sure. As we only have 5 minutes, I have one very concrete question for you. Here we are discussing about what is the position of Europe in this market and how can we improve. Are we able to lead the market? What kind of investment or help or funding will help you to improve our not only you, your sector,
Yes,
okay?
yes.
Don't think,
Yes, yes.
please elevate the view, okay? The sector. Or should we specialize on something very specific, or are we able to really make a difference in the general sector of that you were describing?
Yes, so in my opinion, we've lost the cloud market already. That's now an American and a Chinese thing in terms of chips and in terms of software. So this is already, from my point of view, this is already done. The interesting part now is, especially since in Europe we have this focus on data security and privacy, moving these applications to the edge. And this is something where the American companies are very hesitant because they want to keep this all centralized in a big data center and have the control. And I think for this more decentralized, privacy-focused concepts of machine learning, so having also a distributed learning with a lot of different sensors that all may learn on its own but communicate in a network, I see that for all of these edge applications, we are in a good position because this is a market where currently the Americans have a different strategy. The Chinese also have a clear cloud strategy. And I've given you today a lot of arguments why this cloud strategy will not work out for everything. And there we have a clear part where we can contribute a lot and also specialize on this. So for Infineon, one argument is also this system. The one who owns the system also owns the data. So if we have a sensor system with a sensor, an AI accelerator, and we build the algorithm for the system, then we have the whole system ownership. And I think this is also something where Europe should focus on, combining this with our strengths like the automotive industry or the engineering industries, and build the AI capabilities closely into our machines and connect this directly with the real world, and focus on how to bring this into a constrained environment, and not just use a cloud infrastructure that US companies provide to us.
And another question, last, I suppose, okay. Have you suffered disruptions during the crisis? Have you suffered for the lack of components, of the lack of materials for your work? Are you suffering now, or are you forecasting some problems in the near future?
Not much. For our work, there was no big change. To be honest, the Corona crisis led to a large uptake in personal electronics. So a lot of people bought new headsets and new home electronics. And for an electronics company, this is not the worst situation. So we had a very weak automotive market, but on the other hand, some other markets accelerated. So currently, the Corona crisis, of course, from the automotive sector, it hit us quite hard because Infineon is the largest supplier of automotive electronics. If you look at a BMW, Daimler, or Volkswagen, nearly all of the electronics comes from Infineon. This is a market where we are directly affected and heavily affected. So this is something where we of course also see issues. Also in the long term, for the more home electronics market, this is still in a quite good shape.
But let me repeat, because perhaps I was not very clear. In the side of the supply, okay, did you suffer from lack of components, or all your supply chain is based on Germany or in Europe? That is the question. Do you depend of other markets outside Europe?
Yes, we do, but to be honest, I'm not an expert on our supply chain, so I can't really answer this question. I think that I heard that we bought a lot of stock beforehand in order to, if there would be disruptions or problems, to have enough material on hand. But I can't give you more details on that question.
Perfect, thank you. One just last point. Okay, I saw that you have in the screen in your presentation some slide with the word reserve. Are you okay if we share this presentation and this video publicly?
Yes, I think yes, you can share it.
Thank you, because we used to do that. Okay, but we need to respect your. Okay. Thank you a lot for your participation and your contribution, and congratulations again for what you are doing. Okay.
Yeah.
Thank you.
Goodbye.
Sorry, because I didn't have the opportunity to give the word to the rest. Okay, but I would like to hear now Frank Bosenberg from Silicon Saxony cluster, who has been the person that has introduced us with Burns. Frank, would you give us your view?
Yes, thanks for the opportunity. Hello, everybody. Bernd pointed it out already. As a cluster, we see one aspect in AI where our members also could contribute, which is maybe surprisingly in line with the Green Deal. And this is something that that is relevant for our cluster for more than 10 years now already. It's energy efficiency in ICT. It was pointed out here a little bit that that dedicated chips are far more energy efficient than I would say bulk chips that we all are aware of. And something that is sometimes forgotten is that if we increase the level of AI usage, we will tremendously increase the level of energy demand, basically up to a point where it cannot be covered, even not on a global scale. And so I want to point out here and raise awareness to the fact that all ICT applications have to increase their energy efficiency level to an extent that is not yet on everyone's radar. Otherwise, we will fail in the implementation of this. This is something where our cluster does its contribution now for 10 years already. Infineon in particular is one of the members, and another of our members is Cloud and Heat, which build green computing centers. Yeah, that's my message, basically, mainly to the ICT clusters. Take energy efficiency into account. It's fully in line with the Green Deal. It's an asset that many of you have anyways already, and that's also a competitive advantage of Europe in this AI race. The awareness for the green aspect also in ICT.
That comment is, in fact, very, very aligned with the messages from the Commissioner Thierry Breton yesterday. He animated us to participate in the digitalization of Europe, okay, but also in the green aspects, and so that's quite relevant. Frank, focusing on again, sorry, on the strategic aspects. Do you think that we can lead this market? Can Europe take this kind of this area as one of the flagships for our future?
But whether we can lead the markets, at least it should be the objective. Whether we can make it, I don't know, because we are not the only one in the race, of course, and we are definitely not anymore in a leading position. If it comes to microelectronics and this, we are still in a good position, also with regard to research, etc. But we should strive for the leading position, yes. And it's a big branch, the ICT market, which will see some turns now if we increase the level of energy efficiency. So Europe should take a chance there. Whether we can make it, I don't know. But if we don't start the race, then we have lost already.
Thank you. Sorry, because I am making all the questions today. Sorry. I open the floor now for everybody. Comments, questions, new perspectives?
Yes. Antonio, can I say something very short? Well, I put here in the chat a report from OECD because I think there is another aspect that it's very important, that is the impact of AI in society and in economy. And I think that now that we are going to have the Green Deal and the recovery plan that was yesterday spoke with the Commissioner, I think it will be very important for the clusters and other organizations trying to have metrics and other kinds of forms to see how the organizations deal with AI in terms of the people, the employers, and things like that. So this report is very interesting because it gives some ideas on that. It's another perspective, but I think it's interesting.
Thank you, Jaime. More comments, more questions.
It's Frank here again. Basically, I want to underline what Reimer said. AI has challenges in philosophy, basically, that we have hardly seen ever before in tech changes. I mean, similar discussions were, I don't know, 100 years ago when the car was introduced, whether it's sane to travel faster than a human being could do alone. And now we are on this philosophical question: is what level of command and what level of decision we would hand over to machines. So also here it's important and relevant that Europe leads the discussion, because there are a lot of opportunities in more usage of AI, but there are also certain threats, of course. Personally, I'm a big optimist, and I'm a big pro of AI usage to the biggest extent, but of course, these philosophical and ethical questions remain, and also tech clusters should deal with it very, very, very intensively in order to allow a leading position of Europe. The good thing in Europe is that it can be discussed, that it will be discussed. We have to make sure that that the discussions also not come to an end, but do not stop the technological developments and implementations.
I remember a conversation with Ula. I think that something like 2 years ago, we were commenting about augmented intelligence, which is the application of the artificial intelligence to help us to make better decisions. And that's the mix, the middle point between the artificial intelligence and the human intelligence. Okay, so if we are able to really help us to take the decisions, better decisions, that makes sense for me. More comments, more questions. I would like to hear other experts here with their view. Please don't be shy. We are building a collective intelligence with these sessions, so your contribution will help us to improve.
Hi, good morning. My question is, even in Europe, how are we dependent on one or more companies that do this? I know Infineon, and I was not recalling Infineon when we talked about this market some days ago because of the drones. Are there other companies? I know Infineon is the larger, and Bernd said that also, but are there more? Could we in future have competition, which is also healthy?
Frank, will you, or whoever has
Yes,
information about that?
I will try to answer this because it's a very relevant question, and it's one that is also discussed on the European level. I just clicked the wrong button instead of unmuting. I opened the pause window. So yes, competition is extremely relevant. There is basically only very little competition to this on a European scale still. There's a huge competition on this on a global scale. Europe's problem in this market is that we try to maintain competitive environment for European players while totally neglecting that the competition became global, I don't know, 20 years ago or something like this. And if you look at some reports, everything that is going to be invested in AI or microelectronics as one of the underlying technologies, and no matter how big the sums are for Germany, and they are not low, or for Europe, and they are not low, they are at least 5 times higher in the other markets, in US, and in most cases they are 10 times higher in China. And so what was done 5 years ago in microelectronics with this Airbus of chips, basically we have to overcome this idea of having all competitors within Europe, but we have to unite as Europe in order to remain competitive on a global level. Otherwise, Europe will in 10 years or in 15 years be as competitive as Brazil is now, or Africa. They are not any relevant player in this market on those in entire South America or Africa. In Europe, we still have some players. There's NXP, a Dutch company. There's ST Microelectronics, a French company, and they could compete now with each other, or they differentiate and they combine resources. They act together as European players in order to allow technology sovereignty. That's our keyword. We have to maintain those technologies in Europe. For basically for security reasons. Yeah, and that's also important for AI.
For strategic reasons, you mean,
yes,
no? Also.
Yes, and it doesn't mean that we build walls or that we do not exchange ideas with the other regions of the world. But But for some things, and microelectronics and AI is one of the technologies, it's important that we have the capacities within Europe. And Corona showed this for other technologies. You saw in the last 3 months what is important to have it in your own country, in your own region, or at least in Europe. And yeah, the same holds true for AI and for microelectronics as one of the underlying technologies.
More questions, more comments. The good news is that the commissioner has nominated one of the 14 ecosystems as just electronics, and I think that's and the other is digital. So it's clear that in his mind, in the mind of the European Commission, you are a priority. Would you comment on that, Ula?
Sorry, Antonio, I got completely distracted. I didn't follow because I had a message from my Director General.
Don't worry, don't worry. Okay.
But if you
totally
repeat, but today I'm
yeah,
not too attentive.
we were speaking about the critical character of this field for Europe, for the future of Europe, and the danger of not really helping our companies to compete, to grow, to lose the train of the yeah.
But there, Commissioner Breton has a very firm stand on it, and because for him, Team Breton is not only, of course, DG Grow, but also DG Connect and DG DEFI. And particularly our colleagues in DG Connect and what they are proposing also for the next MFF, the Multi-Annual Financial Framework, is also from a point of view of funding that quite a lot goes in digitalization, and of course digitalization in the sense of new technologies. And the commissioner is also saying that he doesn't think particularly on AI and the applications for AI that Europe is behind. At the contrary, he sees a lot of very good development in Europe, and for this he really wants that it is spread, and he also thinks that the way it is done in Europe, meaning having many different nods on excellence in this area is something very useful. And I know that there are whole programs from our colleagues which are set up from DG Connect in this area. So, but of course, it is important to watch, because we also see in international competition how much others are putting into it. But I think what the commissioner is also always saying, that there comes in then the strength of Europe, meaning that we also have the, let's say, the traditional industries, and that we need to make this link between the two, and that would then generate also a lot of industrial data. And there we need to get it right from the beginning, how to use all these data which are produced and which have a value. And I think that is one of, for him, for the key points, and that's why he wants to set up these EU data spaces, and how the governance of these data spaces will be something very important.
But thank you. Any comment to Ula's words, Frank?
Yeah, I can only underline this. I mean, it's not a new saying that data are the new oil, and definitely that's something where Europe is in the lead. Also, in particular, in its heterogeneous composition. The key is here again European collaboration. I mean, Bavaria alone probably has a good data pool, taking into account all its manufacturing industry and its industrial data, but still it won't be sufficient. A good functioning, well-governed and in line with ethics existing European data pool is certainly key for winning the race in AI or keeping in the race. AI. So I can only urge European collaboration in this field as well.
Thank you. I want to take the opportunity to show you that we have published yesterday video in YouTube for your reference. If you didn't show it, or if you want to review the conference, it was very, very interesting. One of the things that the commissioner announced was the creation of Euro clusters. I am very interested. We are very interested. Ulla, would you comment on that? Could we, or does it make sense to create one Euro cluster for promoting, for example, these capacities of artificial intelligence in the edge from Europe?
So the Euro clusters are the joint cluster initiatives. So that's the new name. And for the moment, our thinking goes along the line that we want to see how we can have the joint cluster initiatives related to the ecosystems, because it's a start. And of course, the way we will launch joint cluster initiatives will be also, let's say, gradually. We will start with some, and then also our hope is to see what other kind of budget could be employed, because only the little COSME money is of course not much, but at least that's something we know we will have, so we can kick it off pretty quickly. And the start would be on on the ecosystems, directly on edge AI. I think because when we look at the budget which is foreseen for digitalization, which is really big, I think we might need to find a clever way how to use the budget which is foreseen from the digitalization, and particularly for the setting up of this digital innovation hubs. And I understood that from the different digital innovation hubs, because normally each region should have one, but then on a member state level, there should be at least one which deals with AI. So each region one, but not each region necessarily AI, but one per member state also on AI. And in the operational programs for this digital innovation hubs, one of the criteria is that clusters can be part of or be a digital innovation hub. This is explicitly written in the operational programs for the digital innovation hubs. This is also something due to what we learned from the cluster expert group that we managed with our colleagues to put this in. So, but we might, even think about having a stronger role, how to set it up, particularly after what the commissioner said yesterday when he afterwards referred to digital clusters, which we are all now interpreting. Did he mean virtual? Did he mean digital? So that might give us, and also to, in discussion with our colleagues with DigiConnect, saying, look, we should see how we can work together, and what can be done for clusters in this field.
Thank you, Ulla. Frank, are you part of a digital innovation hub? Silicon Valley?
Yeah. Basically, we found together with a startup dedicated organization and the 5G lab. It's from TU Dresden and extra organizations. Our daughter organization called Smart Systems Hub, located in Dresden. It's part of the German DE Hub initiative, and it's also part of AI for Germany, so an existing network on AI. Yes, we as a cluster organization are closely interlinked with a digital innovation hub already. And I know this is true also for some other digital clusters, not for all of them, but yeah, there are some good examples.
And are your members participating also in the Digital Innovation Hub?
Yes, we are technology cluster on microelectronics and software. So our members are all part of this value chain, and the hub is our tool, I would say, to connect with application industry. So via the hub and its services, and they deal mostly with co-innovation, we connect to application members within our own region, but partly also already beyond. And we are also working on this on a European scale. But of course, we first collect the experience on a regional scale, and then we transfer it, or then we widen our customer base, basically, because the Digital Innovation Hub also offers in a commercial, still non-profit, but in a commercial environment.
Could you explain what is an application member? Sorry.
So we have hardware and software companies.
Okay, application
the application is all imaginable applications. The energy market is an application from our point of view. So we have the local energy provider as a client in the Digital Innovation Hub. Phoenix Contact, it's a Industry 4.0 company from a different region in Germany. We would call them a machinery sector. It's application market for us. They are a customer. Medicine is in field of application from our point of view. So we look for fields of application, or our Digital Innovation Hub looks for fields of application where the underlying technologies, hardware, software, connectivity in our case, can be applied.
Perfect. Thank you.
Antonio, can I make a question?
For sure.
Yes. Well, we are in Europe. We are making some efforts in terms of quantum electronics. What is your idea about the future of this, taking account all the learnings that we have from this crisis? How can we secure some knowledge and some importance of Europe in this area?
This question goes to me?
I think so. I don't know about quantum
electronics. It's a potential future technology with different with a lot of options, but so far it's still pretty much on a research level. There are one or two applications, mainly in the high security field so far, that have been realized from Chinese players and also from US players. Europe is still on research here. We need to find application fields here which are ready to pay the extremely high costs that are still connected with this technology. Maybe security research could play here a special role from a European point of view, because if you see where those applications are, where quantum electronics is being used right now, it's in NASA environment and also in Chinese space environment.
Yeah, we have a big risk in that area, I think, because as far as I understand, this will be the future. Okay. I will show you our map of. Sorry.
Yeah, it's one potential path of the future. That's important. I mean, it's a potential future technology. No one really seriously can say whether the technology will be the technology in 10 or 15 years. But if it will be the case, then of course we shouldn't be behind. So we have to stay in the race here. Yeah.
As far as this is our map of resources, okay, and here we have very few resources as far as we know. Sorry, because I don't see the name. But too few, in my opinion. Okay, so for cybersecurity, and we will have a session on cybersecurity very soon. It's critical for sure, quantum technology. And cybersecurity must be, as you said before, a strategic issue for Europe, for every country, every area of the world. Okay, so for me, I don't know how is the technology, who is working on it. Okay, who is investing, but we should not lose that trend.
Hello, Antonio.
Yes, hello, Alan.
Hi, this is Alan.
Welcome.
On the field of quantum cryptography, I know that the European Telecom Communications ETSI, they actually have published documents in 2017 on quantum cryptography, and it's connected to 5G. And I guess one of my issues with AI is its probably dependency on 5G. Is that true? And also the other issue I have is with Edge, is there interoperability issues? And if we look at our clusters, I know for certain here in Optitech, we fundamentally look at the SMEs, they're main to us. So if our SMEs have to build software or whatever on 5G, are we depending on foreign infrastructures, such as Huawei? Are they the only ones capable of giving us the 5G we need for AI?
So what would be the way to improve that, Alan?
I don't know. I mean, of course, I mean, you can take the look at going like localism and look at what we have here in Europe, Ericsson and Nokia and so forth, and feed into that. But I think in my experience at going to ETSI, which are based here in Sophie Antipolis in France, they're doing phenomenal work with standards. And I mean, you can have as many family paintings or whatever with networks, but you still have to kind of like obey the standards. And I think the ETSI are doing phenomenal work on that. Again, it's how we factor things in with AI linked to 5G. Do we really have 5G at the moment? And I mean, this is my worry. Like, I mean, like everyone, I don't want to see us depending on whether networks coming from outside Europe. I'd rather focus on Europe, giving us the ability to have true AI on our own infrastructure of the 5G. And then our SMEs building on, you know, our infrastructure that's European. Again, the only thing that I can relate to this is the actual standards that are built on this. And I mean, the only one I can think of at the moment is ETSI do that quite phenomenally. And they do it with AI as well, with ethics and so forth. So if people are looking for a source, they're pretty good. And again, with regards to quantum cryptography, they actually published a document in 2017.
If you can, please send us this reference.
Yeah, well,
you don't mind.
Yeah, no, of course, it's the European Telecom Communications Standard Institute, and yeah, they do excellent work in this field. But again, my worry is kind of the question is, wow, yeah, Edge, especially mobile Edge, it's great, but all these have interoperable issues. So yeah, okay, I'd be delighted. Thank you.
Yeah, you are opening a very interesting question that perhaps we should study deeper in future session. Thank you very much, Alan. Okay, so it's time to close. It's time to close. And I want to thank also Frank, also your colleagues, Bernd, to share with us today so many interesting information. Okay, tomorrow we are going to speak about the France water team as a supercluster. Okay, and on Friday we are going deep on the social housing related to construction ecosystem. So you are all invited to come back to these sessions and contribute. Thank you very much. Bye.
Thanks. Bye-bye.
Bye, Frank.
Bye-bye.
Thank you. Bye.